So here's an example for cosine. Okay, cosine is 0.5, so again the ratio is 1/2. So cosine is x, so it's going to be -1 and 2 this way. Okay, and it doesn't tell us the quadrant. It tells us we know it's in the circle here, but it doesn't tell us the quadrant. So we have to consider another position here, and the other position is going to be down here, because for x's there's this folding symmetry across this line, and so there's my theta 2 right in there. Okay, I'm going to call that one theta 2. So my theta 1 is going to be in quadrant 2. If I do arc cos, I'm going to get something like, I think it's, I forgot what it is. I think it's going to be 2.8 or something, 2.08 or something like that. But because again it's a special angle, we know that that's going to be 60 degrees, so that must be 120, which is 2 pi over 3. Okay, and that's approximately, actually I'm going to use my calculator here. And if I use my calculator, arc cos of 0.5 of -0.5 is going to be 2.09, approximately 2.09 radians. Okay, now to get theta 2, to get the red one, okay, so that angle is in quadrant 2. To get the one in quadrant 3, we were going to use this symmetry. We know that that angle there is the same as a black angle there, theta 1. So we're going to subtract theta 1. So that's where we get this formula. We start at 2 pi, and we're going to go backwards. Okay, so theta 2 is going to be 2 pi minus theta 1, which was 2 pi over 3. So we're going to end up with 4 pi over 3 as my theta 2. Okay, and again, notice that the x position, if I'm going in this direction and rotating in this direction, in the negative direction, I'm going to keep the same x position. So that's why this formula holds true for all cosine values. Okay, for tan it's again has a different symmetry, so we have to be careful with tan as well. So tan equals 1.75 means we have a slope of about 1.7, something like that. Okay, so that's going to be 1.75, and I want to solve for theta. Well, again, there's two different places that establish this slope, because that could have been -1, -1.75, and have the same slope. So one is theta 1, the other one's theta 2. So this one is not a special angle, so we're going to start with that expression. We're going to rewrite it as arctan. Okay, and then we're going to just call that one theta 1, and whatever we get from our calculator, we're just always going to just say is theta 1. So we're going to do second arctan 1.75, and from our this one we need a calculator, and so this one is theta 1 is equal to 1.05. Okay, and there that angle is in quadrant 1, so we can say that that one is 1.05 radians. Okay, so 1.05 radians is going to be that theta. We have another angle that we have to consider, and that angle is going to be over here. Okay, so we'll call that one theta 2. Well, theta 2 is going to be on the other side of the circle. So for tan, we just take theta 1, and we're just going to go to the other side of the circle by using pi. And this is the symmetry for tan. So this is going to be our formula for tan. So in this case, theta 2 is going to be equal to 4.19 radians. Okay, and that's going to be the angle in quadrant 3 that we wanted.